All right, you're up, Koontz.
All right, so I just want to talk about pivoting. So let's say we have a network. Let's say it looks like this. Okay, so router 0 is on a 1.001 network, and it serves DHCP to two hosts. We'll say Kali and P1, P standing for pivot. Pivot standing on 1.003, and then there's a static link that goes to another router, and he's sitting on the 2 network. So the 1 network can talk to the 2 network, and then we have a 3 network over there. And in order to talk to the 3 network, we have to go through the 2 network. Okay, that's what's called a segmented network. Okay, the 1 network cannot talk to the 3 network. The 1 network has to talk to the 2 network to get to the 3 network. Okay, so in Minimega, I built this environment that has 98 routers, and you go from router 1001, all the way to router 99. Okay, so those are doing a little shell script, just a little scripting to make that. So what does that look like? So you start on your first host. We're just going to SSH in, and then for sake of convenience, I took the password off the box. And so I'm just going to SSH into the first node. And so 1003 SSH in, easy peasy. All right, we're going to do that again. So now from SSH on number 1, we're just going to go into number 2. So now we're on number 2. And then rinse and repeat, and eventually you get to 99. I was going to show a video of this, but I don't want to waste 15 minutes of you guys' life. So that's in essence what segmented networkings are. And in order to pivot from one to the other, you have to use technology that lets you do that. And so let's simplify this down and let's make it Windows. So let's take our Kali network, it's on the internet, and it connects to the 1 network. And the 1 network is running a Windows box on 1003. Same static link to the 2 network running 2003, static network to the 3 network running 3003. Okay. So we're no longer dealing with 99 routers anymore. We're just going to deal with, a much smaller network just to understand these concepts. So how do we do this in Windows? So in Windows, the easy way is just to use RDP. So you can nest RDP connections just like you can nest SSH connections. And so from the first box in Kali, you would use X-free RDP to remote desktop into the first box. And then since we know the password, and assuming we know the password for all the hosts, we can just use MSTSC on the box to go to the next one, go to the next one, go to the next one. So here's what that looks like when you go 9 layers deep. Okay. And I built a network where you can go 99 layers deep. I'm not going to show it just because it takes too damn long. But I just use a simple macro that just, logs into the next box, logs into the next box, logs into the next box. Cool. So we have a way to pivot from 1 host to 99 hosts. Pretty easy, just use remote desktop. All right, so what if we need to do something that's not with RDP? All right, so there's a lot of tools out there. So Cobalt Strike has a VPN, but it doesn't work with Windows 10. There's various ways to do port redirection. And then there's a thing called SOCKS proxies. If you go to this website, they'll tell you a bunch of different techniques on how to do this kind of stuff. I want to cover SOCKS proxies. So SOCKS proxies, think of SOCKS as just like a service you can run on a host, and it'll proxy all your network requests through it. So there's quite a few services that do SOCKS proxies. SSH has one built in, they'll do it. Chisel, 3Proxy, RPivot, Cobalt Strike, Invoke SOCKS proxy, you name it, there's probably a tool that does it. So you can actually make one yourself. It's like less than 100 lines of C code. And like it's very minimal to make a SOCKS proxy service if you want to. There's some caveats to SOCKS proxies though. So they're very slow, especially if you want to do port scanning, because they have to take the request for the port and then go to the port, and then there's delay time intervals. It's very slow. And then it's only on a layer 3 protocol level. So like you're not gonna be able to do anything with like DHCP, because it only understands like, oh, I'm sending a packet to this IP on this port, and then it forwards it on. And so anything layer 2 or below, it won't know how to handle. So that's useful for knowing like certain kinds of scans. You can't do layer 2 scans, you can only do layer 3 scans. All right, so how do I do this with SSH? So let's assume we had SSH on Windows. It's not by default, but let's assume we did. All right, well, for the first node from Kali to the 1 box, I would just use SSH, and the magic flag is -D, and then you specify a port. Okay, that creates a SOCKS service on the first server. And then using proxy change, you can say, hey, I want to use port 1234, and that's configured in etsy/proxychange.conf. And then you can run whatever command you want. You can run Firefox, you can run nmap, you can run whatever. I'm just going to use wget and assume there's a web service on the 1 box. And then you could wget through the 1 box to the 2 box. Okay. You can nest these together. So you can say, I want to proxy chains and create a new SOCKS proxy through the first SOCKS proxy going to the second box. Okay. And then you say, all right, I want to use that new config file that I then copied from my proxy chains so that I can get to the 3 network. So you can go from the no network to 1 to 2 to 3. Okay. So this is what's called like a forward lookup. So we're doing like a forward proxy on this matter. And that works pretty well. And that's the way a lot of people do this. Like it's very simple as long as you have SSH. Okay. But what if I don't have SSH? Well, that creates a whole different world of problems. So the kind of like de facto tool of choice a lot of people have been using is called Chisel. It's a Golang binary. It's cross-platform. And it's like 9 megabytes. Like it's a huge binary. AV likes to flag it a lot, so like you have to wait for like the new build or build one yourself. And it supports reverse connections. So what does that mean? So what that means is it phones home and then creates a SOCKS proxy. Okay, so on your Kali server, you're just going to run this command chisel server, listen on this port, and listen for connections. Okay, and then on your Windows box, you're going to take the Windows build of chisel, and you're going to say, hey, connect in client mode back to my first guy on port 8000 at badguy.com, and then create a reverse SOCKS proxy. Okay, and then with that, you can then use proxy chains and then go through it just like SSH. So there's a problem there. We just said, hey, come back home on, from the 1003 network, phone home. Cool. How do I get from 2003 home or 3003 home? Because I have to go through the second box or go through the first box. So what do you do in that case? So with Chisel, it gets complicated. So just bear with me here. So you can create a SOCKS listening service. So if we go to the 2003 box, okay, and we say, hey, with Chisel, start a service listening on 1081. Okay, we can do that with that command. Okay, and then on the first box, we can say, hey, we need to redirect a port back to us. So what you say is, hey, connect back to the first host and redirect port 1081 and say anything that comes at 1081, send it to 2003 1081. Okay. And then back on the Kali box, we say, all right, now that we have a local port that's forwarded through the first host, we want to go through the first host to the second host to the third host. And then with proxy chains, we can proxy chains all that and this wget 3003. Okay, I get it. That's really complicated. That's hard to understand, especially when you get more layers deep. When you get to like the 99th layer, you're gonna be like, what the hell am I doing? So there's got to be a different way to do this, right? Like, I understand, like, if you have like firewalls in the way, like, there's no other way. Like, you have to create the SOCKS pip to go back through the firewall port. It's like open a port and send it back through. But let's say we don't want to use Chisel because Chisel's flagged by AV. Chisel's not going to be around forever. What if I want to use some other tool to do it? All right, that's fine. Let's say we can open a port from one box to another box. All right, so there's no Windows firewall running. Let's just say that we can connect from one host to another once we're in this network. So W1 can directly connect to W2, and W2 can directly connect to W3. And let's say we just want a beacon that can phone home from the last host all the way back to us. So how do you do that? So on Linux, you can use what's called socat. Okay, on socat, you just hop on the first box and you say, hey, redirect everything on 1081 to badguy.com 1081. Okay, and then you go to the second box and you say redirect everything on 1081 and go back to the first box on 1081. And then on the final box, you just say phone home to the second box 1081, and it goes from the second box to the first box to you. So I think it's a lot easier that way, just to run socat and just assuming you have a port open, you're good. But we're not on Linux. Okay, so that's a problem. So Linux, it's not even installed by default in most installations. Like, it's a package you got to install. So a lot of people just use the static binary that someone made for it. Like, this guy's random GitHub, just like use his static binary. He has a script to compile it yourself if you want. And they just use socat on Linux and they just drop this binary in the box and they run it. In Windows, way back in the day, let's go way, way, way back, like 2001, 2000 era. These guys made a program called fpipe. It's a 13 kilobyte binary, and it does exactly what socat does. It just redirects the port from one to the next. And most AVs will flag this, like 100%. So you could like do some sort of obfuscation to the AV, but we don't have source code for it. So you're gonna have to like do some weird techniques to make it bypass AV, and then hope whatever you did doesn't flag AV. Or you can compile socat on Windows, but because socat uses Linux libraries, you have to copy these DLLs from Cygwin or MSys, and there's usually multiple DLLs involved with this. So like you have to take like a zip of socat, throw it on the box, unzip the zip, and then run socat. That's kind of a problem. Like that's not really like safe in an engagement to be like, oh yeah, I want to just drop 20 binaries on your box and then run them real quick. And so I thought about this for a while. I'm like, there's got to be a better way. Like seriously, like no one's ever statically compiled this. Like this is dumb. And so I decided, all right, fine, I'll just go compile socat myself, use MSys, and then MSys has less dependencies than Cygwin. So Cygwin has like 10 dependencies for socat. MSys only has 1. And then I just wrote a simple C dropper that just takes socat's binary, writes it to disk, takes the DLLs, writes it to disk. So it writes it right to the temp folder. And then I UPX pack that. So I have a 1 megabyte socat binary that when executed, will do the same thing Chisel does if it's 9 megabyte binary. And so you can go to my website, you can go download that if you want. Here's my quick little demo of it. It's just take your binary and just run it, and you can run whatever commands you want. And I mean, it looks the same. You can pass whatever flags you want to it. You know, when you control C it control C out and kills it all. So very simple little thing, but I just wanted to show like, you know, pivoting is like a very critical concept for a lot of people. And a lot of people don't understand how it works because like how many times you nested 99 times layer deep in a network or even 3 layers deep. And like a lot of tools break when you get to that level. And so understanding like what to do in those cases is actually pretty important. And I think it's like one of those things like they don't really teach you anywhere. You kind of have to like learn yourself. And I had some fun playing with this. I had, you know, Windows boxes 99 layers deep, and I was still getting these tools to work. So it's kind of cool. Anyways, that's my demo.
Cool. So I had a question about creating the MSys environment. Is that pretty lightweight and easy to install in your dev environment, Mike?
Yeah, so I just had, I mean, it's just a single binary. It's just like installing Cygwin. It's just called MSys2.
Okay.
And it actually uses the same package manager that Arch Linux uses, which is kind of weird to like throw that on a Windows box and just like run this binary. It has like the Arch Linux package manager. And you're just like, oh yeah, I'm gonna pacman install, you know, GCC. It's like, what the hell is going on? But no, it's pretty easy, straightforward.
Nice.
I didn't have too many difficulties compiling socat. It was just I could not find a way to statically compile it, and I like tried for a while. I remember like back in the day, like there used to be like these programs that used to like package together exe with all the dependencies and stuff. Mm-hmm. And like malware authors were like using this to like, you know, distribute their malware. And so like they'd like take like some pirated software and then just like add their backdoor into it, and then it would phone home with the software. And so like there's like tons of different products out there. You used to do this, like Thamida, VMware had a product at one point in time, like Thinstall, that did this. Like it just like took a bunch of different binaries, packaged them all into one. And I don't know, it's those different times, like Wild West back in the day.
True. Yeah,
I was kind of like based off those days, like, oh yeah, I'll just make a file dropper just like they did.
Sure. Yeah. What was really cool is that you use fpipe, and I have used fpipe because I needed a socat equivalent, right? But yeah, it's really flagged by AV, so that is kind of a bummer. So yeah, I think that's pretty cool. So one question I have for you, and I don't have that much. So I use socks, but I don't really know the details. I believe there are 2 versions of it, right? But I think one is perhaps like the standardized. Everyone uses this one version, and then there's the other version. Is it 4 or 5 that? You know, is that supported, or what's the difference between the 2 different versions of socks, Mike?
Yeah, so there's socks 4 and 5. So SSH uses socks 5. So socks 5 added like authentication and stuff, and there's not much in terms of differences between the 2. So like if you have like a interpreter shell, you can deploy either like a socks 4 pivot or a socks 5 pivot. It I don't know. If the tool works with socks 4, just use socks 4 because you'll have greater compatibility. But if something's not working, just like change it to socks 5. I don't have a good way of like detecting between the 2, like what is it using, you know, but yeah.
Cool.
Hey, Mike, that was a really cool demo. And this is just kind of, you know, a learner question, right? How difficult is it to ride a port that's already open on the system, or for this pivoting, do you have to open ports like in order to get the pivots to work? That just simple question from someone who has only pivoted once in his home environment.
Yeah, so Chisel has a way to like create a port out. So instead of having to have ports being open on the inbound side, you just have to have ports up on the outbound side, which is pretty common for a lot of firewalls. So Chisel is like the kind of like de facto standard and like what to do in that instance. If you need to like reuse a service, so like say like there's a web service run on a box, there's a program called regeorge, and regeorge is like, let's say it's a Windows web server IIS. You could deploy an ASPX file and it'll pivot your traffic through the ASPX file. And so it looks just like web server traffic on that service. And so you can reuse some of the services that are already open. What I typically do is I just turn off a service that's open in the firewall and just use the port for that service. That makes sense.
Yeah, definitely. Thank you for sharing.
Yep.
Oh, so Mike, I was curious about when you went through the Chisel stuff. So that first node, is it the fact that you ran two Chisel binaries? One was first to call back, and then another one was to create the link you needed to jump to the second, the next hop, Mike? How do you use Chisel during that first hop there?
Yeah, so this command out here, this Chisel, this one creates that port redirection, basically like socat would do.
Yeah.
But it does it all internally without having to have an open port.
But
So,
are you running two Chisel binaries there? Oh wow, that's dirty.
yeah, it gets dirty quick.
Okay.
Yeah. Like hopefully like you're not too far in an environment like this. Like you'll eventually get to a box that can phone home to you. Like where you're not, nested 4 layers deep. It's pretty rare to even get to like the second level of this, like yeah. So
okay. Awesome.
yeah.
All right.